And again the tip of this vector, and this would be in a straight line. Just below the head, you'll have a head of this vector. This is what you do. This is how you get x component. Now, if you don't do all this in the first way of resolving the vector, if you're resolving this vector straight away, if you have a vector like this and you're resolving it straight away, that means you know this angle and you're resolving it straight away, then the x component, the x component from via this method should be the same as x component of this method. That means the point to which the triangle will be formed will be the same as the point as you in the other case when you break this vector along xy plane and then you form a triangle like this. You can see that geometrically when you break the vector like this and you form a triangle like this, or when you form a triangle like this, they form the same base. Can you see that? If you have a vector like this and you are breaking the vector into the component of xy plane and the component along z-axis, then this component, when again you break this vector into x component and y component, then the base of the triangle, suppose is this, is the same as the base of the triangle otherwise. Because, and by now you must have figured out that it will be the same, because if the vector is like this and you have made a triangle like this, so this head is actually just below this vector, and when you again break this vector along x-axis and y-axis, then this head is just below this head. Now see, if you lift this line upwards, stretching it and lifting it, then the head of this line will coincide with the head of this line. So what I'm doing is I'm lifting this line upwards. The line is kept like this, and I'm lifting this line upwards like this. Now there's a vector already here. When you lift this line upwards, they coincide. So the triangle that you're going to form, right angle triangle that you're going to form in this method, is going to be the base is going to be the same. So either you take the component directly or you break them into a component along in the xy plane and z-axis, and again you break the component in the xy plane into x and y, you're going to get the same thing. So this you should be able to see through geometrically, because when you're going to study 3D geometry and more of vectors in maths, your geometrical visualization has to be strong. So you have to see more than what is shown to you. You have to look more than what you have been taught. You have to see through more than what you read in the book. That's what I'm trying to say. When you have been given two methods of solving the same thing, you should actually think about it deeply and should realize that via both the paths you are actually reaching the same destination. So your thinking is more important than just listening and reading. Okay, so that now completes the theory of addition and subtraction of vectors. We'll solve few problems. We'll start with easy ones, and then we will study further the multiplication of vectors. So actually we are halfway down. We have studied the addition and subtraction of vector. After this we have to study quickly multiplication of vectors, and that would complete vector. But still we are just halfway down. Okay, so let me start with few very easy problems. Suppose a particle is at position 2, 4, 5, and it went to a new position, suppose 3, 6, 7. Now this is a position vector. We show it like this. It means that the position vector, this is the position of the particle, the position vector, initial position vector would be 2i cap plus 4j cap plus 5k cap, and the final position vector is 3i cap plus 6j cap plus 7k cap, and they're asking you what is the displacement that has occurred in this particle. Displacement is simply final position minus initial position. Writing the displacement vector shouldn't be difficult for you. The displacement vector would be AB vector, and that would be final position minus initial position. That would be I cap plus 2j cap plus 2k cap. This is the final position. This is the displacement vector. Find, suppose there's a vector 4i cap plus 5j cap plus 6k cap. I'm asking you direction cosines for this vector. Direction cosine, remember we studied when we were child, when we were 10 minutes smaller. Okay, so, direction cosine L is x component upon the magnitude of total vector. So magnitude of total vector here would come out as root 77. Okay, so L is 4 upon root 77, M would be 5 upon root 77, and N will be 6 upon root 77. Easy? Suppose there's a vector I cap minus 3j cap plus 2k cap, and there's another vector B vector is equal to 2i cap plus 4j cap plus 3k cap. Now the question is, which vector should be added to these two vectors so that the sum of the three vectors would be a unit vector along y-axis, positive y-axis, positive direction of y-axis. So this is again simple and easy. Let the vector be c vector. So what they're asking is a vector plus b vector plus c vector should be equal to a unit vector in the positive direction of y-axis, that is j cap. Okay, so a vector is I vector. If you do the summation of a vector and b vector, you'll get 3i cap plus j cap plus 5k cap plus c vector should be equal to j cap. Fine. C vector you can get very easily as minus 3i cap plus, minus 5k cap. Simple. Okay. Okay. Let's solve another easy one without pen and paper. They are saying there's a vector, a vector. The magnitude is a, and it makes equal angle with all the three axes. Then what is the component of this vector along each axis? Oral, simple, 10-second type question. The answer would be b a root 3. Very easy. Okay. Now let's solve a relatively better problem now. Suppose a vector is given as 3i cap plus 4j cap plus 5k cap, and b vector is given as 2i cap, 12i cap plus 13j cap plus 5k cap. Now they are asking to find a vector c such that magnitude of the vector c is same as magnitude of vector a, and c vector is parallel to b vector. This is conceptually good problem. You should try this one out. Hoping that you have tried this, what we would do is, if c vector has to be parallel to b vector, in this kind of thing what we basically do is, if you have a b vector like this, you find a unit vector parallel to b vector, and we know how to find a unit vector. You find a unit vector, and once you have the unit vector, you multiply it with any number to get the desired magnitude. You multiply it by 5 times, it is this vector of the desired magnitude. You multiply it with by 10 times, you have a same vector parallel to b vector of the desired magnitude. So the idea is you find a unit vector along b vector, and we know how to do that. We will call it as b cap. We have studied unit vector before, and we have done that before, so it shouldn't be a problem for you to find b cap. B cap, a unit vector, would be found by dividing this vector with its own magnitude. The magnitude here would be 13 root 2. So b cap would be, you divide it by 13 root 2.